and this is math class. Today we want to look at polygon, finding the sum of the interior angles of a convex polygon. That's what we are looking at today. Okay, so we want to look at the definition of polygons, then definition of the convex and the concave polygons and vertex. So we'll go to all that. Polygon is simply a plane shape with straight sides. Most times the sides are usually 3 upward. You can't have a polygon less than 3 with sides less than 2. So anything with sides, plane shape with sides from 3 upward gives that's a polygon there. So examples of polygons, we have triangles. Of course, you know triangles have 3 sides. The rectangles have 4 sides, so it's a polygon too. Pentagons too, it's an example of polygon. We say circle is not a polygon because it has a curved side, it doesn't have lines, does not have sides. It's you just draw a circle by drawing a curve or something circular. Okay, so circle is not a polygon. All right there. So let's look at types of polygon. We have the regular type of polygon and the irregular polygon. You can look at the difference. Look at the shape of this one. It's very straight and easy, straightforward. Look at this. Whenever you're having this crazy kind of drawing or something abnormal, that's what you call irregular polygon. So let's look at convex polygon and concave polygon. What is a convex polygon? A convex polygon has no angles pointing inwards. In the convex polygon, look at this. This is how many sided figure? This is 1, 2, 3, 4, 5. This is a 5-sided figure. So this is a pentagon. Shapes. A shape that is that has 5 sides. A plane shape of 5 sides, 5 different lines joined together, is called a pentagon. It's called pentagon. So this is an example of a polygon, but this is a convex polygon because all the angles are there is no angle pointing inward. All the angles are just like that, outside like that. Literally say everything, all the lines, nothing is coming inside the diagram. So everything is just like that. So more precisely, there is no internal angles that is more than 180 degrees in a convex polygon. So let's look at a concave. I know you have heard the word cave before. Have you heard of the word cave before? Just let it settle in your mind. That's what we use to differentiate. If there are any internal angles greater than 180 degrees, then we'll say that it is a concave polygon. Say concave. Look at this. This one has angles pointing inward, like a cave, caving in. Look at it. So they gave you a tip there saying that concave has a cave in it. Look at this. Look at this coming inside, coming inward. You know the other. Look at the difference between the two. See the convex, nothing is coming inward. This one concave, caves in. You have something, one angle is coming in. So usually the angle is more than 180 degrees. Because once we have this, we'll be talking about angles at a point, and then this one now will definitely be more than 180 degrees. So it has internal angle that is above 180 degrees. So we call it a concave polygon. Anytime you have a polygon that has angles, that has internal angles that is greater than 180 degrees, or you have something coming in, you have the diagram coming in at one point and then coming out in another place again, that's a concave polygon. So that does not occur in a convex polygon. Okay, so let's look at some terms, some concepts that we need to understand in solving problems with interior angles of polygons. We trust that in the next class we'll be able to look at the exterior. Definitely the word interior means internal, something internal. So interior angles of polygon is talking about the angles inside the polygon. So let's just look at some basic concepts as we so that we can understand. What is the sum of the interior angles of a triangle? What is the sum of the interior angles of a triangle? The total number of the total of angles in a triangle. So we will just use this illustration. Already we know that. I know that everybody knows that it's 180 degrees, but let me use this illustration to buttress that, so that when you begin to look at other polygons, you just follow the same procedure. Okay, how can we use this to find the missing angles in a triangle? Look at it. In everybody knows that the sum of angles of a triangle, sum of angles in a triangle, with the total will always give you 180 degrees. So we say A plus B plus C equals to what? 180 degrees. So look at this diagram. This is a triangle. I'm sure you know that, but it's just turned upside down. So what is the measure of the third angle? That's an example there that we want to solve together. Look at this. We've been given this angle A, angle B, then we're looking for angle C. Look at angle A is 29 degrees, angle B is 105 degrees, and angle C is not given. So they are asking us to find angle C. What do? A plus B plus C will give you 180 degrees. The sum of angles, the total of angles in a triangle will always give you 180 degrees in Nigeria, in Ghana, in America, all over the world. That is how it is done. So sum of angles in a triangle will always give you 180 degrees. So having said that, you have this angle, you have this, and you don't know this, and you have been told that the total must be equal to 180 degrees. So how do you solve that? Let's go to that. The measure of the third angle is this. This is how we measure the third angle. The interior angles of a triangle will always add up towards 180 degrees. So if I have been given 2 out of the 3, that will give me 180 degrees. I'm looking for the third one. What do? I will just add this plus this together, take away my answer from 180 degrees, then I will have this place. Okay, so let's go and do that. The sum of the angles that I am given is 29 degrees. This is angle A and angle B. I'm looking for C, that is right here, but I've been given A and B. So the total of my A and B added together, 29 plus 105 degrees will give me 134 degrees. So if I want to find my C, what am I going to do? I will just say the third angle is equal to what? 180 degrees. Take away 134. That will give me 46. So if you plus 29 plus 105 plus 46 together, it should give you 180 degrees. I hope you understand that. Okay, so let's proceed a little bit. So if you want to divide a polygon into triangles in solving problems of finding interior angles of a polygon, all right, I already told you that a polygon is simply a plane shape that has from 3 sides above. From 3 sides above, you can have a polygon with 5 sides. What is the meaning of side? Lines that you draw together to form the shape is called your sides. That's a layman language. Okay, so the sides are the lines that you join together to form that shape. All right, so the corners are like your vertex. Okay, so you draw a diagonal to the closest vertex at the left that is not adjacent. You will understand all of this by the time we begin to take our example. So repeat for additional diagonals until you reach the adjacent at the right. All right, let's go. This is an example of a polygon. Look at that. Let's count the number of sides this has. 1, 2, 3, 4, 5, 6. This is a 6-sided polygon and it's called an hexagon. Hexagon. A 5-sided polygon is called pentagon. A 4-sided polygon is called quadrilateral. This is an example of a quadrilateral. Let's count the number of sides. 1, 2, 3, 4. So this is a quadrilateral right here. A rectangle is an example of a quadrilateral. A square is an example of a quadrilateral because it has 4 sides. That's 4 lines joined together makes a square. So you call it a quadrilateral. Quadri is 4. Anytime, most times when you in mathematics you come across anything quadri, is talking about 4. Okay, so this is a 4-sided polygon and it's a quadrilateral. 6-sided polygon is called hexagon. 5-sided polygon is called pentagon. Is that okay? All right, then on and on. 8-sided polygon is called octagon. I'm still going to show you on the screen by the time we get the names of the rest of the polygons, the one that that you can still memorize. So let's count triangles in an hexagon. Having we spoke about dividing into triangles the other time in the previous slide. Look at this. We're trying to share this hexagon into triangles to see what we will have. Having triangles we can form from the hexagon. Look at it from this point now. We draw out one triangle here, I cap that another triangle here, and then I cap that another triangle. Can you see how many triangles I have? This is 1, 2, 3, 4. I am able to get 4 triangles from an hexagon. Let's look at how many triangles I can form from a quadrilateral. From a quadrilateral I can only get 2 triangles. Can you see that? All right, so let's move forward. So that is going to bring us to the formula that you need to calculate the sum of the internal or interior angles of a polygon. When you are asked to find the sum whenever you have a question asking you to find the sum of the total of the interior angles of a polygon, this is a formula you will always use. So sum of internal angles of a polygon is equal to n minus 2 times 180 degrees. N is talking about the number of sides that polygon has. So you count the number of sides of the polygon minus 2 times 180 degrees. We give you the total, the addition. That is why they wrote sum. The addition of all the interior angles of that polygon is what you will get by this. Then if you are asked to take note of what I said, because all this will come out in your assignments. Now you will come across question asking you for the sum of the interior angles. Sum is different from measure each angle. Sum is the total sum of all the angles in the polygon. Whenever you are asked, now look at the formula you will use to get that. N minus 2 times 180 degrees, and I said n stands for number of sides, and I told you what sides means earlier on. The lines that you join together to form the shape is your sides, in a layman and simple language to understand. Okay, so n is the number of sides, the number of lines that you find on that polygon. So whenever they give you, just go and count how many sides does it have. Then minus 2, then you multiply by 180 degrees. That is when you are finding sum. When they ask you find the sum of the interior angles of this polygon, this is the formula you're going to use. Don't forget. Another question you come across in your assignment will be measure any angle in a regular polygon. They can give you a polygon and say measure the angle, tell us the value of this angle. This is the formula you're going to use. N minus 2 times 180 degrees, then divided by n. That means you will first find the total sum of angles, sum of the interior angles in the polygon, then you will divide it by the number of sides that polygon has. We're going to take an example so that it will be easy for you to understand. Okay, look at this diagram. I have done something like a summary of different types of polygon. The sum of the interior angles, or I told you interior is the same time as internal angles that are inside the shape. Okay, look at this. All right, so let's go. The first shape I have here, remember I told you that polygon is any plane shape starting from that has sides, starting from 3 sides upward. Is that okay? All right, so triangle is the minimum you can have. That is 3-sided. Quadrilateral is a 4-sided polygon. A 5-sided polygon is called pentagon. Did you see the spelling of pentagon here? Okay, a 6-sided polygon is called an hexagon. A 7-sided polygon is called septagon or heptagon. Each of the whichever one you choose is okay. Okay, so an 8-sided polygon is called octagon. And then I think we should stop there for now, because you still have decagon, you have nonagon. You have decagon, that is a 10-sided polygon. So let's just stop at 8 for now. Look at the sum of interior angles. Sum of the interior angles in a triangle is 180 degrees. Okay, so that means each angle, if this is an equilateral triangle where you have all the sides equal, then each angle will give you what? 60 degrees. Okay, I'm going to tell you the formula you would always use to find all your angles whenever they give you questions. In a quadrilateral, the total sum of angles in a quadrilateral is equal to 360 degrees. All things being equal, each angle will be 90 degrees. 90 in 4 places. Remember that a quadrilateral has 4 sides, so 90 in 4 places will give you 360 degrees. A pentagon, the sum of angles in a pentagon gives you 540 degrees. Each angle is 108 degrees. Look at this. Hexagon, the total sum of angles in an hexagon gives you 720 degrees. Each angle is 120 degrees. That is provided all the angles are equal, because sometimes they can give you an hexagon where you have an angle a little bit bigger than the other angles. At that point, you will have to fall back on your formula. You don't say by force everything is 120 degrees each. I hope that is clear. So because there are times that they can give you an hexagon that is not regular. It's an hexagon, quite all right, but the angles are bigger. There is differences in the angles. This can be 20 degrees, the other one, so that will tell you there are some other angles, but everything must total up to come to 720 degrees. But some can be bigger than the other. You can have an angle that is 140, that is 150. Of course, it will not be more than 180 each. So you can have one 180, then another 140 degrees. That is, you would have seen it in the diagram, that is not equal. Is that okay? But in normal day, when it has equal sides and equal angles, everything, each angle should come to 120 degrees. Okay, let's proceed on and on. An heptagon, the sum of angle in an heptagon should come to 900 degrees. Each angle will be 120. That is when everything is, like I said, equal. So let's go down to the formula you would always use to find the, in case you don't know, I mean, just count the number of sides. You don't know how many, some of the angles, you don't know it. This is the formula you should always use to find. Whenever they give you any polygon that they give you, n stands for the number of sides. So the first thing to do is to go and count how many sides does this polygon have. Once you count, let's assume you counted and it has 10 sides, for instance. Okay, what will I do? 10 minus 2. When I get my answer, that is 8. 8 times 180 degrees will give you the sum of the interior angle. Sum means the addition of all the interior angles of the polygon. If they now ask you to find one of the angles, what are you going to do? You look at this. You first find the sum by using n minus 2 times 180 degrees. Then you will divide. If they say tell us each of the angles, you first find the sum, then you divide by the number of sides that you have, which is n. That is why you have all over n here. I believe that is clear. You will understand as we take examples now. So let's look at this example. Sum of internal angles is equal to n minus 2 times 180 degrees. So that means if I have 10, like I said earlier on, if you are given an object, I mean a shape that is 10-sided like this one, look at this. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a 10-sided polygon. What do I do? 10 minus 2 times 180 degrees. So that will give me what? 8 times 180 degrees. That's 1440 degrees. That's the sum, addition of all the angles in this entire angles, the addition, the total of all the angles in this entire polygon. If they now ask you to find each of the angles, tell us what is each of these angles. Each of these angles, what will you do? You will divide this sum all over the total number of sides you have, which is 10. So that would be 1440 divided by 10. That gives you 144 for a regular polygon, like I said earlier on, where everything is equal. A regular polygon where all the sides are equal. When you have one longer than the other, one angle bigger than the other, it will not. You will just do this and you will follow another method. I will show you how to always get that. But when everything is equal like this, for a regular, you know, I told you the one that is abnormal is irregular polygon. When the one that is normal, all the stuffs are equal, they are just well drawn, like that, smooth and well drawn, that's a regular polygon. Once you start having some kind of crazy drawing in the stuff, it's irregular, it's abnormal. That's the word. So let's proceed. Okay, what is the fourth interior angle of this quadrilateral? I told you a quadrilateral is a four-sided polygon. Look at this. 1, 2, 3, 4. The first thing to always do is to count the number of sides that polygon has. So this has 4 lines. 1, 2, 3, 4. It has 4 sides. A four-sided polygon is called quadrilateral. So, all right, you can have, it can be a square, it can be a rectangle, it can be, I don't know what I want to call this. Is this a rectangle or something? It's not. Look at it, but it's irregular. You can look at it. It's irregular. You can see that even the angles are not equal. This is 82 here. This is 113 here. This is 51. So you know it's not regular. It's abnormal already. It's a regular polygon. Okay. So what is the fourth interior angle of this quadrilateral? Because when it is regular, all the sides would have been equal. And I told you the total of this, the sum of angles in a quadrilateral is 360 degrees. So if it was a regular polygon, everything would have just been 90, 90, 90. But it is abnormal. So one is bigger than the other. It is abnormal. So look at this. 82 is irregular. This is 82 here. This is 51 here. This is 113. This one is bigger than the other angles. So it means all the angles are not the same. Okay. So because of that, we have to use formula to calculate it. Okay. So what is the formula I told you will always use to find the interior angle of a polygon? I told you it's n minus 2 times 180 degrees, when your n is the number of sides, abi. But in this case, you have been given 3 of the angles already. You are just looking for 1, and I know that my total will be equal to 360 degrees. So do I need to follow all that process? And I can't even use that method. I can't use that n minus 2 times 180 degrees because it's not a regular polygon. Everything is not equal. so I will not be able to use that. So let's go and do this. I'm going to calculate. I'm going to add the 3 that I am given. Since out of 4 I've been given 3, is 1 I am looking for, and I know that the total must be equal to 360 degrees. So just the way we solved that of the triangle earlier on is the way we're going to solve the sum of interior angles of a quadrilateral is equal to 360 degrees. It's fixed in Nigeria, in London, in America. That is how it is. The total of angles, the sum, addition of all the angles of a quadrilateral will always be equal to 360 degrees. In this quadrilateral, you have angle A plus B plus C plus D. And then I've been given 3 out of the angles. So I'm just looking for angle D. I've been given angle A, angle B, angle C. Look at that. So look at this. I'm just going to total all that I've been given and take it out of 360 degrees. So give me the one I am looking for. Okay, so I have A to be 113 degrees. This is 51 degrees plus 82 degrees. When I add all that together, it gives me 246 degrees. Okay, so that is A plus B plus C. And I'm looking for D. That's the fourth angle. So the total of the 3 I have found, which is 246 degrees, I'm just going to take it out of 360 degrees. And then I have my D equals to what? 114 degrees. That is it right there. Okay, so let's take another example so that you'll be able to we'll be able to wrap up for today. Another example, each of the interior angles of a regular polygon is 156 degrees. How many sides does the polygon have? Is it 15, 16, 17, or 18 sides that it has? Each of the interior angles, now they've got an answer for me. They've told me that everything is a regular polygon, so that means everything is equal. Everything is equal. Each of the interior angles, but they didn't tell me how many sides it has, so I don't know whether it's an hexagon or a pentagon or a decagon or I don't even know. But they've just told me that each angle is 156 degrees, and that polygon is a regular polygon, which means that all the sides and the angles, they are equal. Okay, so let's proceed. How do I solve that? I'm going to use the formula for one angle of a regular n-sided polygon. That's what I'm going to use. We know that one of our angles, they've told us that all the angles are 156 degrees each, but I don't know my n. I don't know how many sides. That's what I'm searching for. I don't know how many sides the polygon has. So what do? What is my formula? My formula is n minus 2 times 180 is, n minus 2 times 180 is what will tell me the total or the sum of the interior angles of that polygon. So it's that same formula I'm going to use. N is the number of sides that you know that the polygon has. So n minus 2 times 180 equals to, what am I going to do? I will multiply both sides by n. So I have n minus 2 times 180 is equal to 156n. So what do I do here? When I expand, okay, n times 180 will give me 180n minus 180 times 2 will give me minus 360 is equal to 156n. Okay, I'm going to try to collect my like terms here. Now I'm sure you'll be able to do that. So collecting my like terms, what do? I'm going to subtract 156n from both sides. So I have 180n minus 360 minus 156n is equal to 0. So I'm going to add 360 to both sides so that I can knock off this to the other side and collect my like terms. I know you have done that in algebra. So 180n minus 156n is equal to 360. This minus turns to plus when it climbs to the other side. So 180n minus 156n is equal to 360 degrees. Okay, so let's proceed. Subtracting both sides now. What do you have? 24n is equal to 360 degrees. And we're dividing both sides by 24 so that I can knock off 24. I want my n to stand on this because I'm looking for n. N is equal to what? 360 degrees divided by 24, which will give me what? 15. That means that polygon contains 15 sides. That polygon has 15 sides. If you want to check if your answer is correct, just go and do that. Put everything back. Put 15 in the side for n minus 2. Multiply your answer by 180. Get it. Go back and work backwards. You will be able to tell whether you are correct or wrong. Till I come your way next time. Bye bye.